Welcome. I want to talk about validation in Vue, and it can become more complicated. So I lead a software development company in Vienna. We have a few bigger projects with Vue, and I want to share with you some insights from one of our projects. So the stack was in the backend we used Laravel, and we used Vue, of course. We used Bulma and Buefi. I never know how it's pronounced. And we used Vuex for the data handling. It was quite a big project where the goal was to create a like a price calculation tool. Roughly 2,000 man hours for concept and development. So it was quite a big project. And so the typical solutions didn't work well in that context. And I want to talk a bit more about that and how we came to our project-specific solution and what you can learn. I'm just using JavaScript, no TypeScript. I'm not sure how everybody knows it or not. And also, I try to talk more about concept and patterns than actually like libraries or code. First of all, I'm not sure if everybody of you knows Vuex, so I'm just trying to explain the very basic concept. So in the Vue application, you normally have your app root, and below that you have components, and those components can have other components, and so on and so on and so on. And data is handled that you have your data in the root, typically, so in this case in a parent, and then every time you want to pass data down, you're using props to pass them down. And if the child changes data, it sends them up emitting an event so that this goes to the parent. In this context, that looks pretty simple. In bigger applications, you soon have a parent of a parent, and then you start caring a lot about just emitting and catching events, and it gets, yeah, it doesn't work well. So this is where Vuex comes in. It's it's similar to Redux from React, and the basic idea is the Vue component, instead of sending to the parent, it directly dispatches an action which saves the data in the data store. So the data store is decoupled from the components, and then if the store internally changes data, that state gets rendered again in the Vue component. And so you have one single source of truth, which is a Vuex store. This is where the current application state data is saved, and components don't need to know how they are related. All right. So this is the basic example of how to handle validation in Vue from the documentation. It's very simple. The idea is here. In your app root data, you have field 1 and 2, and above you're using a vModel to bind that input data to the input. The user can type in input, and then if he clicks save, you would call your check for method, and that just checks if the value here, for example, is more than 3 characters. If not, you get an error, and then it aborts if you have errors. That is very simple, and what's happening here is that you only save data from the input to the store when someone clicks submit. That pretty fast becomes a problem, because if you have dependent properties, or if you have some inputs but then you want to show a calculation result or something, inputting data would not automatically update those fields, and so that's not a good solution. So you actually want to save the data directly to the Vuex store. So this would be done like here. So I'm using Vuex map fields. So what it does, these fields look like normal data fields, and they have a getter and a setter. And so every time someone types in the input field, that triggers a mutation, goes into the store, and Yeah, so everything is already changed directly in the Vuex store, but now our validations are only used when I would save it to the server. The big problem here is if I input here some invalidator, I break my whole application. Division by 0 or some of these things which you don't want to deal with. So that's also a very naive and bad problem. So to take a step back, what's actually the actual problem behind is that we don't have one value. We have one value in different representations. So if you take, for example, euro, a monetary value, in the input it might look like 0, 5, which is the localized German way of typing a number. In the representation where I want to show it, I would maybe add the euro sign before. In my normalized value, so the thing I'm saving in my Vuex store, I might want to have it in the as a real number, 0.5, so different type. And maybe the server formats all those as a string with a precision afterwards. So actually you have the same kind of value in different representations. There would be a very good pattern to solve that, which comes from domain-driven design, which is called a value object. So you would have a value object, which is my number type, and I have different setters to input any of those daters, and then different getters to get them in the other representation out. That works really well, for example, if you work with Laravel or in any backend application thing. The problem here is this is our core domain, just the tables related to calculation of prices. So we have thousands of objects in our Vuex store, and if we would use value objects, the size goes like ×5 or something, and that would mean like performance problems which we cannot accept. So value objects are not a solution, and the other solution is heavy normalization. So as soon as we get data from the server, we normalize it to our structure, which is the only way it's allowed to be in the application. So all our components which are handling data become way simpler because there's just one thing they can expect to get. And then if we save again to the server, we also denormalize or normalize to the server format. And every time the user inputs something, we make sure that it's also normalized before it goes into Vuex. And this reduces the complexity of the other code a lot, because I always know what I can expect. There was also a talk from one of the developers from Preact, and it's their latest Preact. They did exactly the same. They made sure that they normalized a bunch of stuff, and the library is now half the size from before, almost. Yes, so I explained that. So that worked really well. The other thing is we can have actually multiple states. It's not that I just have a number. So let's say I have a number and the number must be greater than 5. There would be a valid input like 7, and that state can exist. There could also be an invalid like 4, but there's a third one, and this is the problem. If the user starts typing, they maybe write something like 3 dot, because they're in typing, and this is not any number. This is just weird, or like minus, because they want to type -1. So you have non-numeric things. And so we have to, so the second and the third should actually go into this Vuex store, because if it's just a normal validation error, I want to show the validation error, but I could still calculate the things based on that and can give a lot of feedback. But if I get something like this, I should never get it into my Vuex store, because it will probably break some other code of the application. And that's very likely because you're not guarding against these things, because you expect normalized data. So yeah, so the way to solve that is to actually make sure that invalid, like really invalid things, never go into Vuex. So if you have a backend, it's pretty simple. The way how you process the requests is linear. You make sure that the user actually logged in and that they're allowed to change it. Then you do some normalization. Then you do the model validation. Things like, is the number bigger than 5 and these kind of things. And then you can store it. In the front end, it's more complicated because in the front end, the user is always changing and we're not just like getting one final thing we want to save and we can say yes or no, but it's changing while the person is typing. So a naive approach would be to just say like, oh, if the person loads the page, we make sure that the person is logged in. And then if someone types in my input field, it triggers with vModel an action to save in Vuex. Then we have a new Vuex state, which we can then validate and only allow saving if it's valid. But what we discussed before, we want to we want to normalize before, but we want to add this step here of basic input validation and only lets data through which looks usable. And then if the state is really valid, so no error messages anymore, the save button is enabled, the user can click save, it's converted to the server format, saved there, and when it comes back with the, we again normalize it and put it back in our Vuex. All right, so let's get to a bit more code. That actually is, yeah, let's skip that for a second. Sorry. All right. So here's an implementation of that, and of course a very shortened version of that. In our template, we just have an input which binds the value with vModel, and then we also care about the input blur because there we are actually wanna maybe reformat the data a bit. This is a component which is called, I don't know, like my input field, and it accepts a type like euro or euro precise or integer or whatever, and it accepts a value. And then what it does is when it first loads up, it gets there's a small typo here. I condensed the example. It gets the value, this dot value, and already reformats it from the Vuex normalized version to the way it's supposed to be in the input. So that would, for example, make sure that it's a German number format. And this is our initial values which the Vue input starts up. And then we have our two main watch methods. The first is let's start here. If the user changes something, this watch here would be triggered. The person types into the input, and this one is triggered. So there are more rules here in the real one. I'm just showing you a few examples. So here, if the type of this input is integer, I don't want the user. I don't want to give the user the possibility to write decimals. So if they want to start with typing, I'm removing the character, so they are never able to write decimals. Yeah, you can do a lot of these things here. Then this one is also here important. If the value is actually, so if that's supposed to use the normalized value. So if the normalized value is not a number, so something weird is going on, I'm setting it to 0, and so it never gets to the store. And here I can apply some other things. For example, if the number cannot be more than 500 and the user types 700, it will decrease it to 500 automatically. And now that we have this, so here, let's say we have a valid case, like the user types 50, and now 50 is saved into the Vuex store. This will trigger, so Vuex creates a new state, and that state will be rendered. And this is the tricky part, because that fucks up a lot of, actually that's in many applications weird, because that would change the state of the input. And so if I'm using a different formatting, for example, if I typically write euros with 10 or 50, I was an example of 50.00, and I would now do the whole loop, the input would change from 50 to 50.00, and when the user maybe was typing, he wanted to 500, for example, it would change his input, and so you can't type ahead. And so what we have to do with this watch value is to actually make sure that if we're using the same precision, it's still the same value. And only if the value really changed, we're re-rendering it. And then on blur, I can make sure that it's always shown the same way. So if I type 50 and I move to the next field, it would automatically format the input as 50.00, which is the standard format for displaying a monetary value. All right, so that was a lot, but that was the hard part. And then there comes a simpler part, which is now that we have, for example, a numeric value, we can make a store field which encapsulates not only this handling, but also saving to Vuex. And what I'm doing here is this implementation is almost exactly the same as the normal map fields. The only thing which I'm changing here is I'm saying, hey, if this is not a valid number, don't save it to Vuex. And just this small thing, make sure that I'm only having valid numbers in Vuex and that they are always formatted in the correct way, because I'm just applying my normalization here. And so all of that is encapsulated in this one store field, and I never have to care about that in my whole application. I can use it like 500 times and it always makes a predictable result. And yeah, that works really well. So I'm using it like this. I'm saying, hey, I have a store field. I give it a label. I define the type. I'm using Vuex with submodules. So this is where I'm defining the submodule I'm using. And I'm defining the path in the Vuex store where the value is bound to. And that's it. And so the code where I'm using, where I have like a long form with a lot of inputs and they have different types and everything, it's just really simple and readable and removed all the complexity. And yeah, and it's a bit bigger because it does not only implement numeric values, but it also implements string values and things like that, you can imagine. But the two files I showed you, this one here, which is the numeric input validation, the numeric input, and the store field, in the final solution with implementing required min lengths, max lengths, number sizes, and all that kind of thing, they're both less than 400 characters, lines of code, not characters. That would be amazing. Yeah, and if you have this or something like this, it's not about the exact code, but it's about the concept of saying, hey, Vuex only has normalized valid data. It maybe has validation errors, but it's like the correct type and the usable format, and handling everything before. And then, of course, you'll see if you do that in 3 components, you see the pattern, you can abstract it to something like this. And that might look a bit different in your application. Yeah, if you have this, you can do a lot of stuff. For example, let's say you have dependent things which are, so for example, let's say that's a made up example. if I would disable SMS sending on my product, it would make sense to remove all the SMS packages. And this can be implemented then in the Vuex store in the subscribe, because I know only valid stuff is coming into Vuex. And so in Vuex I can say like, hey, subscribe to any mutation of product SMS enabled, and then I'm just removing all the packages. And this is super easy to read and is stable, and all your data consistency logic is in Vue and in Vuex, the one single source of truth. And now the input components for your editors, they don't have to have any logic anymore. That's why they look so simple in the end, because all the logic is placed somewhere else and independent of the actual form where the user changes stuff. And this is different than most Vue applications you'll find. Most examples and things like that you find on the web, they always have a lot of business logic in the form component. And that does not work in projects of this size. Also, if we now know that the data is normalized to exactly the same format in my Vuex store, it's very easy to know if the user actually changed something. So I have 50 inputs on the field, the user types something, maybe removes it again, changes it around 5 times. And to check if it's dirty, it's just really simple, because what I'm doing here, when I first init the store, I'm just making a clone of the data and saving it as server data. That's already normalized data. That's the important part. You have to first normalize it, and when it's normalized, you make a copy. And then you can simply check if it's dirty by comparing your current state to your initial state. And yeah, with fast DB equal, that is really fast, even on big things. Yeah, so the input component does not have to know anything about context anymore, which you'll find also in typical examples of Vue validate or Vue validate, that the outer form has some context and understands the context. Now my single input, no one has to know the context except Vuex. The one input field just knows, hey, I'm an input field for something, and these dependencies and everything is handled in the store. Yeah, and it's only emitting valid things. We had that. All right. On top of that, I added cleave input mask. I'm not sure how to pronounce it. So basically, it would actually have an input mask on inputs, like it shows the euro sign before or shows me some structure, how a phone number is supposed to look, things like that. Yeah, the other things are not that interesting for you. Let's see how we're in time. So how much could you follow me so far? Yes, no, so. Okay. So that's one final thing. This was quite fucked up to implement. The basic idea of this thing here was that administrators of the platform should be able to find threshold validation. So they want to say, I don't know, some input needs to be above 5, stuff like that. But also they maybe want to say all the products counted together must at least have a monthly a charge of 300 euros or something like that. And at first we had that implemented like specifically, like, hey, we calculate some things, and that became, on one hand, it became a bit messy. On the other hand, requirement was that some of the rules were actually hidden, so they could not be in JavaScript, they had to be on the server. because they have some metrics and they should not be shared with everybody. And the way we solved that, and it was quite an unusual but funny solution, was there's a library called cake.php hash. There are similar libraries. What you can do is you can define a rule like this. You will say object.any dot some other object.any where the ID equals something dot price. So on the server I can define these kind of rules, and then I want to validate them on the client. The problem is since these are replaceable things, you could, for example, say like here, if this object here has a value, I don't know, a flag of true, only then check for the price here. And so you cannot statically validate that. And you cannot just check if the rule applies, because it depends on your current data. Depending on the current input data, the rule might apply or not apply. And and here at the top we define what we had before. We define our current field path. This is what's going on in Vuex. And then here we can define validation rules. And the way this is implemented is, of course, in our own store. Let me just find the interesting part. Yeah, so what I'm actually doing here is I'm taking the current state of Vuex. I'm finding all the passes which match, and I'm setting a honeypot there. And then I'm applying the server-side cake hatch and checking if it finds the honeypot. And if it finds the honeypot, then the validation rule needs to be applied on that. And then we had to do, and then we have some automatic error messages and everything like that. So now we could define a huge amount of those rules just on the server, and don't need to change anything in the application, but still can push new rules. Yeah, I think that's something maybe you have to can think about. And of course, that was super unperformant in the beginning, so we had to delay it after the initial rendering. But then it was really cool, and now changes from the client are super easy to implement because we have all of this built up. And so if they want to add a few fields, if they want to add a few validation rules, it's just 1-2 places in the backend, and the application can handle everything. All right. Thank you. Tables look like this. So there's a lot of data, and you can see some of them are invalidated, like not able to change depending on other properties. So it gets quite complicated. Key takeaways: normalize everything you get into your application at first and on user input, and then your life becomes way easier because you never have to care about, hey, I'm getting the right type, I'm getting the right something, because it just, you know what to expect. Never, and that's connected, never save something in Vuex which has the wrong type or the wrong format or something, because it will fuck up your application very easily. And and handle all business logic as far this kind of like data logic in Vuex. That makes your life easier. If you want to see specific code, it's a huge project, as I mentioned. Feel free to write me or ask me. And thanks for listening.